Welcome back to our online training series. In this session, our focus will be on the optimal creation of data objects for effective use. We'll guide you through each step of the process and provide a practical demonstration to help you understand the key concepts of data object creation. By the end of this session, you'll be ready to unlock the full potential of data objects in Legos. Let's dive in. In our continuous efforts to achieve faster data response times and optimize the system's performance, Intenda has developed a streamlined approach to data object creation in Legos. By adhering to the guidelines that follow, the Frax's platform's data processing capabilities and the overall user experience it delivers can be significantly enhanced. First, let's define the role and function of data objects within Legos. Data objects are the fundamental units of data in the system, encapsulating data and operations applicable across various data sources. They serve as the foundational elements for organizing and processing information across a spectrum of applications, including but not limited to write-back services, API endpoints, analytics, and ETL processes. So, why is it important that data objects are optimally configured? The reason for this is that data objects often rely on large, remote datasets, and suboptimal configuration of these can lead to significant delays in response times. Performance optimization is a collective responsibility of every Legos user. To mitigate the risk of slow responses and maximize overall system efficiency, it is essential that every member of your team involved in the development of data objects plays a part in ensuring that they are optimally configured. Efficient data processing is integral to Legos' success in providing a seamless user experience. By defining data objects, understanding the importance of optimal configuration, and recognizing that this is a collective responsibility, your team can achieve significantly enhanced data processing capabilities. When discussing optimized data response times and enhanced system performance, the importance of building data objects effectively cannot be understated. Your team's success in this hinges on your ability to grasp the intricacies of your data, its intended use, and its relationships. Before you start building data objects, it is important to understand what they are required for. You need to know precisely how your data will be utilized and where it resides, as this forms the foundation upon which your data objects will be constructed. Intenda recommends a layered approach to data object development. This begins with the creation of base data objects that serve as the bedrock of your data structure. These base data objects must accurately reflect the structure of your base tables and encompass all entities necessary to satisfy the business need. It is imperative to verify attribute data types and names meticulously during this stage. In addition, transforming and molding the base data to fit the specific requirement is very important at this level. Push-down capabilities should be activated for these objects, as this will push down the query to be executed on source and will drastically improve response times. Base data objects are key in laying the groundwork for all subsequent transformations and operations. Think of them as the building blocks upon which you construct your data infrastructure. By ensuring their accuracy and completeness, you set yourself up for success down the line. Once your base data objects have been created, their respective owners must conduct a verification process to ensure that they accurately represent the data and meet the business requirements. Once verified, these base objects can be published and used inside other data objects. Now, let's consider caching. It is best practice to cache your base data objects, especially when dealing with large datasets. Doing this enables you to query the data directly on your compute infrastructure, bypassing potential bottlenecks caused by network issues. There are two options for caching: manual caching or scheduled caching. With manual caching, periodic data refreshes are necessary to ensure that the data remains up to date. Configuring a scheduled caching mechanism automates this process, ensuring timely updates without manual intervention. For extensive datasets with unique identifiers, implementing a scheduled delta cache is highly recommended. With this approach, only the data that has changed since the last update is cached, thus ensuring efficiency and reducing unnecessary overhead. Once you have created your data baseline, you can proceed with using your base data objects to construct federated data views across different hierarchical levels. In cases where these federated views are constructed from cached data objects that reside on the same data source, the objects in question will be seamlessly executed against the cached tables, significantly enhancing response times. It is important to note that when using only cached data objects, the push-down feature should be turned off. This is because the query needs to be executed on the Spark cached datasets to ensure optimal performance. The capability to join tables, transform data from various sources and create objects that span multiple levels is what makes the Frax's platform so powerful, and opens up a world of possibilities for Legos users. The key to successful data object creation lies in a hierarchical approach, ensuring that you build your data objects on each level to satisfy the data requirements of the higher levels. Think of this as being like building a pyramid, where each level relies on the foundation laid by the previous level. By meticulously constructing your data objects level by level, you can ensure that your federated data views are robust and comprehensive. An important advantage of this approach is that fields can always be added at a later stage. Rather than being locked into a rigid structure, Legos affords you the flexibility to adapt and evolve your data objects as your needs change. Crafting data objects to furnish the required viewpoints for your respective applications can involve various levels of the data hierarchy and substantial volumes of records. Prudent caching practices become essential when dealing with such vast amounts of data. By caching data objects that are ready for use, your team can ensure swift access to crucial datasets when querying from applications. This is especially critical when data objects consist of data from different data sources. In such cases, a strategic approach to caching allows for latency issues to be mitigated and ensures seamless access to data, regardless of its origin. In summary, when creating data objects, meticulous planning with an emphasis on optimal response times is pivotal in ensuring a satisfying user experience. By leveraging caching practices intelligently, performance and responsiveness can be optimized. The data objects you create in Legos represent dynamic data transformation tools. By using them adeptly, you can streamline your data processes and drive fast and reliable access to information in your organization. In short, optimized data objects enable you to harness the power of the Fraxsys platform to maximum effect. Thank you for watching this video. In Part 2, we'll provide a practical demonstration to showcase the concepts that underpin optimized data object creation in Legos.